Hello students, welcome back to your science class. So students, in the previous class, we had completed with the chapter and that is atoms and molecules. And now we will going to start with a new chapter and that is gravitation. Talking about this chapter student, that is gravitation, what is a gravitation? We have seen in the previous section of the physics class in which we have understood the motion of the object. We have understood what is a force, and out of that we have seen that there are different types of a force which act on an object, which we can include as a frictional force or a magnetic force or muscular force is there, student. In that there is another kind of a force which we called as a gravitational force. This gravitational force is what it is. It occurs because of the force exerted by the earth. So the earth used to attract the things around it, towards itself, that we called as the gravitational force. So the force which is exerted by the earth on any of the object, making it to, or because of that the thing get attracted towards that of the earth, is called as a gravitation. Okay, so this force is called as the gravitational force here. So now by this we can say here that the motion of the object which occur because of the force which is exerted by that of the earth is called as the gravitational force, and this phenomena in which the object get attracted towards the that of the earth is called as a gravitation. Now, the gravitation is also influenced by the weight and used to vary with the place to place, the weight of the object. But let us try to understand about the gravitation, students. So, you see that anything which is present around us, like moon is there, it used to goes around that of the earth. When we used to throw the object in the upward direction, it will reach us to certain height, and obviously it will falls downward. Why is it so? So basically this led the foundation of that of the gravitation. It was Newton who was sitting under a tree, and when an apple fell on him, he started thinking that why the apple fall downward, why the apple does not fall in the upward direction. So basically he thought that is the thing which we used to throw in the upward direction, it used to come in the downward direction. So it is because of that of the gravity, only because of the force. There is some force which is there in that of the earth which help in attracting the things towards itself. Okay, so everything which is attracted towards that of the earth, it is because of the gravity only. Now, let us try to understand this with the help of an activity, that how the moon or motion of the moon basically occur. So we have taken a piece of a thread and we used to tie it with a small stone at one end. We hold it with a one end and start reeling it round, or start moving it around. Then what kind of a motion that we find out, students? So basically when we tie it with that of the thread and starts moving it, and when we release the thread, what we will see, what is the direction? So basically it will we will find out that it will move in a circular path in a certain speed, and then it will changes the direction at every point. So the force which makes it, which help it to keep on accelerating or keep on moving in a circular path, it is acting towards the center, and such kind of a force is called as a centripetal force or a center seeking force. Now, in the absence of this force, the stone it flies off along a straight line, and straight line will be what? It will be a tangent to that of the circular path. Now, let us, so obviously when we used to leave it, then the object is moving tangent to that of the circular path, and the motion of the moon or motion of any of the celestial object around another celestial object, it is again because of the law of force of attraction, or force of attraction of the earth, and that will pursue it to move in a straight line. Okay. So this is how the gravity actually works. In the solar system, student, you will find out that every object, every one object will use to attract every other object. Okay, and this led to the foundation of the another law which we called as a universal law of gravitation. What is a universal law of a gravitation? So basically every object in this universe used to attract every other object with the force, and this will be proportional to the product of their masses and inversely proportional to the square of distance between them. It's a very very important, that is the universal law, student, that every object in the universe attract every other object with a force which is proportional to the product of their masses and inversely proportional to the square of distance between them. Okay, so here force is directly proportional to the product of the masses and inversely proportional to the square of distance between them. Okay, now see here, there are two objects, one is A, another one is B, and both of them are having the masses. One is having the mass that is capital M, and another one is having the mass that is a small m, and the distance between these two is what? That is D. So what will be the force which is acting here? So it will be equals to F is equals to G capital M into small m upon T square. That is what? That is the force F. Okay, so this law is applicable everywhere, students, and that is because of that it is also called as a universal law of gravitation. So by this law we have understood here one thing, that is the force between two objects is what? It is inversely proportional to the square of distance between them, and the force of the is directly proportional to the product of the masses. Okay, so force is product of the masses and force is inversely proportional to the square of distance between them, and when we combine together we will get that force is what? It is directly proportional to capital M small m upon D square. Now, by removing the proportionality, we get the proportionality constant or constant of proportionality, which we also call as a universal gravitational constant, and it is represented by capital G. Okay, so this is called as the universal gravitational constant. Okay. Now, let us move on and try to understand this universal gravitational constant, student. So, if we want to find out, basically, we are saying that the formula for it is F is what? This is F is equals to that of G capital M small m upon D square or R square. Now if we want to get the value of the capital G, so this D will comes to this side and this 2m will comes to this side. So in a short we can write it here, that is, in short we can write it here as G is equals to F into D square upon M into M. Okay, so this is how we can find out the value of the g. Now, with the help of this, we can get the SI unit also. What is the SI unit of a force? That is Newton. D square, it is represented at meter square. Upon this is kg, this is kg, so kg square. So, Newton meter square per kg square. This is what, this is the SI unit of that of the G. It is also written as you can see here, Newton meter square per kg square. Now, what is the value of the capital G, students? So, the value of the capital G, it is represented as 6.673 into 10 the power minus 11 Newton meter square per kg square. Okay, so this is how we can accept, or we can get the value of the G. Now, we will going to find out what is the some of the questions which is related to it. So here an example is given, and that is mass of the earth is 6.10 the power 24 kg, and that of the moon is also given. It is 7.4 into 10 the power 22 kg. So the two objects are given. One is the mass of the earth and another is that of the moon. So mass of the earth and moon is given. Here it is written mass of the earth and mass of the moon is given. Now, if the distance between the earth and the moon is given as 3.84 into 10 the power 5 kilometer, calculate the force exerted by the earth on the moon. That is capital G is equals to 6.7 into 10 the power minus 11. So here the distance between the earth and that of the moon is what? 3.84 into 10 the power 5 kilometer. And that of the capital G is what? 6.7 into 10 the power minus 11 Newton meter square per kg square. So by this we get by the help of this we can get the value of the force, and this will be equal to 6.7 into 10 the power 11 again into 6 into 10 the power 24 into 7.4 into 10 the power 22 upon 3.84 into 10 the power 8 meter square, and by this we get the value, that is 2.01 into 10 the power 20 Newton. So this is how we can get the force which is exerted by the earth on the moon. Now let us try to understand here the importance of the universal law of gravitation. What is the importance? This question is really very important. So the first one is that will help in binding the earth. So this is the first thing, that this law of gravitation help in binding the binding that of the earth. The force helps the binding the earth. Then the second one, the motion of the moon around that of the earth. So the motion of the moon around the earth was any celestial object, when it starts moving in with the other, then again the motion is actually following the law of a gravitation. Similarly, the other one, like that of the planet around that of the sun, also follows the universal law of gravitation, or it is because of the universal law of gravitation. The tides which is formed, it is because when the sometimes the moon and the sun reaches to the earth closely, due to which a gravitational force is exerted by it and the tides is formed. Okay, so this is the importance of the universal law of gravitation. Now moving to the next one, and that is free fall. When we talk about the free fall, students, so basically, when we talk about the free fall, basically we must know here one thing. See, any object, when it moves towards the center of the earth, it is because of the gravitational force. So whenever an object falls towards the earth under a force, we say that object is in the free fall. But remember, when an object is moving downward, there must not be any kind of a other force acting on it. Okay, and such kind of a fall is called as a free fall. So when only the force of a gravitation is acting on it, or the acceleration which is produced in that of the object is due to the acceleration due to gravitational earth, or acceleration due to gravity, such kind of a fall is called as a free fall. Now, what do we represent the acceleration due to gravity? So basically, acceleration due to gravity, it is represented by small g. So unit of the g is same as that of the acceleration only, and that is meter per second square. Okay, so small g is also called as acceleration due to gravity. Now, according to the second law of motion, student, we know that force is what? That is equal to the product of the mass and the acceleration. Now, what happened? Let us try to assume that we have thrown an object which is having a mass that is small m. So here we can represent the force which is will be equals to mass into acceleration, and the acceleration is produced due to acceleration due to gravity. So instead of writing here F is equals to ma, we can also write is equals to F is equals to m into g, mass into acceleration due to gravity. Now, using the same one, now see, we know that F is equals to gmm upon d square, and F is also equals to mg. So when we equate both of them, then what happen? This m and this m will cancel each other, and it will be g capital G m upon d square. Now this is what? This is a relationship between the small g with that of the capital G. It is really very important to understand that, because most of the time question related to is asked that what is the relationship between that of the small g and that of the capital G together. Okay, so this is how we can find the relation between that of the capital G and that of the small g, students. Now let us try to understand the value of the small g. So as you can see here, it is really important. See here, small g is equals to capital G capital M upon R square. Capital G is what? 6.7 into 10 the power minus 11 into 6 into 10 the power 24 upon 6.4 into 10 the power 6 ka whole square. When we will simplify all of them, student, we will get the value, and that is 9.8 meter per second square. So this is how we can get the value of the small g, and the acceleration due to gravity of the earth, it is represented as 9.8 meter per second square. While solving the question, many times it is also written as a 10 meter per second square. Now, let us try to understand the motion of an object due to the influence of that of the earth. So, basically, in the previous chapter, student, we have understood the three equation of motion. And the three equation of motion was what? That is V is equals to U plus AT. Then S is equals to UT plus half AT square. And V square is equals to U square plus 2AS. Now, in terms of the gravitational force, students, instead of there is some changes, although the meaning is the same, but there is some changes. Like in the first one, you can see here it is written as V is equals to U plus AT. So A is what? Acceleration. Now when this acceleration is because of the gravity, we used to call it as a acceleration due to gravity, and we can say here V is equals to U plus GT instead of the term that is AT. Second one, S is equals to UT plus half AT square. Again here, see, S is what? That is the distance, and you know that when we throw any object in the upward direction, or it will come in the downward direction, this is what? This is the height. This is the distance traveled by it, which is represented by height. So instead of using the word S, we will going to use the word that is H. So it will be h is equals to ut plus half. Now a is what? That is acceleration. Now this acceleration produced due to the gravity, we will call it acceleration due to gravity, that is half gt square. Similarly, in here, in this case, v square is equals to u square plus 2as. Again, v square is equals to u square plus 2 into acceleration due to gravity, that is g into h. So v square plus u square is equals to 2gn. So this is how we will get the value of all the three. Now let us try to understand here some of the questions related to it. So here a question is, that is, a car falls off a ledge and drop to the ground in 0.5 seconds. Let g is equal to 10 meter per second square. So what is the speed striking to the ground? So basically speed is equals to what? Here what are the things given? That is the g is given, student. Then the initial velocity, because it was the car started with initial velocity, so u will be 0. Acceleration due to gravity is there, and we have to find the final velocity. We know the formula, v is equals to u plus at, or b is equals to u plus gt. So instead of that, we will going to use the word here, v is equals to u plus at, and by putting the value here, we will get the answer, that is 5 meter per second. Similarly, the next question is that what is the average speed during the 0.5 meter? So average speed, we know that it is equals to initial velocity plus final velocity, that will give divided by 2. So initial velocity is given as a 0, final is given as a 5. So when we and divided by 2, so 5 by 2 will be equals to 2.5 meter per second. Now the distance travel will be equal to was s is equals to ut plus half at square, and u is 0, that is why it is written as a s is equals to half at square. Half into a is given as a 10 and t square is given as a 0.5. So answer that we will get here, it is what? 1.25. So with the help of this equation also, we are able to get that of the value of the whatever that we wanted. Like if we want the value of a time, and or value of a final velocity or initial velocity, so or even the height also, we can find it with the help of these three equation of motion, which is under the influence of the gravity. Now let us move on and try to understand the weight and mass, students. When we talk about the mass, what is the mass? That anything which is content, any matter content, or any something which is any matter content in an object is called as a mass. Any object consisting of a matter in it is called as a mass only. And the mass of the object, it remain constant, it do not changes its place from one to the another, it remains the same. That is what? That is the mass of the object. Now if we talk about the weight, student, so weight is what? It will be, it's a kind of a force which is acting on an object whose mass is m. So when the weight is applying on an object, so it will make the object to move move it towards the center of the earth. So it used to produce the acceleration, and that is represented by acceleration due to gravity. So because of that, we can say here that the force here is the weight, and this will be equals to mass into acceleration due to gravity, that is mg. So the difference is in between that of the mass and that of the weight. Mass remain constant, but the weight do not remain the constant, because the value of acceleration due to gravity, it used to vary from place to place, and due to which the value of the acceleration due to gravity, it used to vary from place to place, and due to which the g value, so it varies from place to place. So weight of the object also vary from place to place. How can you prove that? If we compare the weight of the object to that of the moon, we will find out that it will become the 1/6 weight of the moon. How? For this we can derive it. Generally we know that according to the universal law of gravitation, if the object is kept on the moon and on that of the earth, so the formula for finding that of the weight of an object on the moon is, as you can see here, Wm is equals to G capital M upon Rm square. So this is the weight of the object on that of the moon, and this is the weight of the object on that of the earth. So when we will compare both of them, then we will get, first of all, when we will write here the values, students, so by multiplying it with that of the 6.67 into 10 to the power minus 11 into 7.36 upon 1.74 10 to the power 6 ka whole square, then we will get the value here. The weight of the object on the moon is 2.431 and the weight of the object on the earth is 1.474 into 10 to the power 11. When we will divide both of them together, it is equal to 0.6, which is almost or approximately equals to 1 by 6. So by this we came to a conclusion. This is really important. That is, the weight of the object on the moon is equal to 1 by 6th of its weight on the earth. So if suppose our weight was 60 Newton in that of the on that of the earth, so what will be the weight of the moon here? So 60 into 1 by 6, so it will be equals to 10 Newton will be the weight of the object on that of the moon. So the sixth one, it will be 1 by 6 of the weight of the object, students. Now see here, there are two questions. First of all, the mass of the object is 10 kg. What is the weight? Obviously, weight is equals to mass into acceleration due to gravity. Acceleration due to gravity is 9.8 and mass is given as 10 kg. So when we will multiply the acceleration due to gravity with that of the with the mass, we will get the answer, that is 98 Newton. Similarly, when the object is there whose weight is given as 10 Newton, and if this weight is on the earth, what will be the weight on the moon? So here again we can see 1 by 6 into 10 or 10 by 6. So this will be equal to 1 by 7 Newton will be the weight of the object on that of the moon. So this is how we can get the value of the weight of the object on that of the moon. Okay, so how we can find the difference between the mass of the object and how we can find the weight of the object.